Okay, we're gonna do a discussion on this pre-June exam. So I sent you this. So let's go over the solution. The question paper is just there. So for this one, first question solve for x. So they ask you solve for x here for 2 marks. So on this one, you can just say x. Let me use a red one. You can just say x equals to 0 or x minus 1 equals, as long as there's 0 here, you can say x equals to 0 or x minus 1 equals to 0, x equals to 1. That's how you get the 2 answers quick, as long as there's a 0 here. Some of you, what you do is you multiply inside, which wastes your time, but then it still works. So you're going to have x squared minus x equals to 0, and you use quadratic for a, 1b minus 1c, 0, and then you still get the 2 answers. Now, it's a waste of time because you only get marks for this. Doing the quadratic, you're not getting any marks. Sorry about that. 1.2, this one, check the question paper. As long as you have this correct to 2 decimal places there, just means that you're going to use straight quadratic formula. So you're going to go straight to a quadratic formula. I'm sorry about that. Just leave it. So here, again, look at what you're getting marks for. So you're getting marks for substituting into the correct quadratic formula and 2 marks for both of them. That is, it's not 1, it's 2 marks for both of them. So if one is wrong, you don't get a mark. You don't even get 1 mark. You get 2 marks for both of them being correct. So make sure you run off correctly. If you don't run off correctly, you might lose 1 mark and so on. But just make sure this one is just correct substitution into the quadratic formula, which is on your answer sheet. I mean, not answer sheet, formula sheet at the end of the question paper, and you'll be sorted. The second method, that's where they're using, what is this? Completing the square. So that's one way you find half of 2, square it, so it's going to be 2, 1, and then you square the 1, then you add it both sides, all of that. So this one, please just forget about it. Just use quadratic formula and finish. 1.1.3. So 1.1.3 you can solve it in different ways. So there's this one, there's this one, there's this one. So let's just go through them quickly. So this one, it's that one where you can change the 125. Remember, the x is an exponent, so that means you're solving using laws of exponent. So that means you're going to have 5 to exponent x equals to 5 to exponent something. That's what you want, so that you can drop the exponents and solve for x. So in this case, you can start by just changing the 125. That is, you're going to have 5 to exponent x equals to 1 all over 125, this one alone. You can use your calculator. You just press 125, equal sign, shift, and then find the fact button, and then you'll see it's going to write it as 5 to exponent 3. So it's like that, and then according to laws of exponents, you should know how to do this part. Put it negative 3, therefore x equals to negative 3. Bases are the same. Next one, this one, instead of changing the 125, 1 over 125, you change the 5. So this one says you can take the, let me put it this way. So you can write it as 5 to exponent negative 1, negative x, basically. This one. Again, just use the other way if you're just confused. And then after that, the 125, you also change it. So this one, the negative 1 times negative x gives you back the x. Why are we doing that? Because now you can change this to 1 all over 5 negative x. This side, you can take the 3 out, you have 1 over 5, and then you put the 3 there. This works because if you put the 3 inside, it's going to go to 1, it's going to go to 5, still going to be 1 over 5 to expand 3. So now you're going to have the same base as 1 over 5. You just say minus 3x equals to 3. That's how they do this one. Let's move. I'm erasing quick, but you can just pause the video. This one's logs. So according to logs, this will be equals to, so x, that is the x. Oh, let me just use the answer. So according to the answer, the x, this will be equals to the log of the base. So you take this one. So the exponent is equals to log of the base. Then in here, you just put this one. And then press your calculator, you get negative 3. Next one, you multiply by 125 on both sides. Change the 125 the same way, 5 to exponent 3, add them, drop them. Then you're going to get the same thing. 1.1.4, inequality equation. So this one, again, it's already factorized. The only thing you need to know is, depending on which method you use. So first and first, critical points. Critical points are already solved. As long as it's 0 this side, you don't need to multiply the 2 brackets. So this just means that x minus 3 for critical points equals to 0, or 2 minus x equals to 0. Therefore, x equals to 3, x equals to 2. That is, you just move the x. Or if you move the 2, it's going to be minus 2, and then you divide by negative on both sides. That is, if you have negative, negative. Divide by negative, get 2. So you have the 2 critical points. That's why you have 2 and 3, 2 and 3. Now, if you're using the parabola method, that is this one, what you need to do first is, remember, you need to know whether it's Milo or Frown. To do that, you just multiply the x's. So this x times this x is negative. So you're going to have negative x squared. That means you have a negative there. Have a Frown. On your Frown, put 2 there, put 3 there, the smaller one this side. Then beyond there. Now, you go back to your equation, it says greater. That means you're looking for where the graph is above. So you're looking for this. And if it's above and it's one region, so that means it's from here to there, this region. You just say x, you put like this, always, if it's one region, from where it starts to where it ends. Just like that. For this other method, what you do is, just erase here the critical points. So for this other method is, you draw a line, put your small, then the next one there. Now to find this positive, negative, positive, negative, you take values. Take a number that's less than 2. That is, let's say negative 1. Then you put it here. You say, okay, negative 1, where you see x. 3, so you're going to put it, so you're going to put it here. Use a different color. I'm struggling. Okay, there. Okay, so you're just going to put it here where you see x. So I put negative 1 here, and I'm going to put another negative 1 there. Then you check the sign, you'll see you're going to get the negative answer. Then you find a value that's between 2 and 3, like 2,5. You put it here, press your calculator, you'll see it will be positive. That is if you're not using the parabola one. So it's either you use this or you use the other one. So you choose one, don't use both. Now with this one, you're just going to look at, it says greater than is positive. So you're going to look at where it's positive. So according to that, it's positive here. So from here, it's that way, and then from here, it's that way. So it's between both of them. So that's why the answer is between 2 and 3. The other methods, let's just leave them. Still the same thing, but then they divided by, they took out the negatives and divided and so on. 1.2.1. So 1.2.1, they're asking for each value. So they gave you, for each values of x will g of x be undefined. So you start with g of x. So g of x is equals to minus 4, as you can see there. X minus 3. So for which values will this be undefined? Undefined just means that here 0 will make this 0. So our x minus 3 should be 0 for undefined. Always the numerator should be 0. So if you solve for x, you move the 3 that side, you're going to get x equals to 3. Always when you find, you look at the denominator. So for x, if f of x equals to g of x, that means you just equate the two equations. So as you can see, this is the equation of f of x, this is the equation of g of x. You just equate them, then you solve for x. That is, you multiply by x minus 3 because you don't want fractions. That's how this cancels this. That's how they ended with this step. Then you multiply the 2 brackets or move the 4 first, whatever way you choose to do. But then you're going to multiply the 2 brackets. Please don't say x plus 1 equals to minus 4, x minus 3 equals to minus 4. Please, this is wrong. Don't do that. Anyway, so after that, you just multiply. Again, from here, you can factorize or you can use quadratic formula as well. That is, x is equals to minus b plus minus and so on. You have a, b, c. A is 1, b is minus 2, c is 1. Then you're still going to get 1 and 1. 2 answers, both of them are 1 and 1. And then 1.2.3 state whether the graph of f is a tangent to the graph of g when f of x is equal to g of x. So for a tangent, you just need to understand, for a tangent, you just need to have it touching one time. So when you said they're equal, we just want to see how many times they touch. So if you have 2 answers that are different, it means it touches 2 times somewhere. Here we found only one answer, basically 2 answers that are the same, x equals to 1. So if it touches 1 time, it's just a tangent. Tangent touches once and goes away. Tangent touches twice. So yes, the graph of f and the graph of g have equal roots at x equals to 1. That's the reason why it is a tangent. Because of the previous answer, basically. We only got 1. X. If we got 2, it's going to be a second, not a second, but it's going to touch on 2 points. I think the best one is this one, which is at x equals to 1. Next one, 1.3, 12 minutes. Jeez, it's going to be long. 1.3, if 3 to exponent 9x equals to 64. So they gave you that said if 3 to exponent 9x equals 64, and then 5 to exponent the root of p equals to 64. Oh, both of them are equal to 64, okay? Now, without the use of a calculator, find the following. So they gave you this one. So find that. Now, the whole idea is to look at what you have and what they gave you. So this one is almost the same thing as this one. While this is almost the same as this one, just that now it has a square root. So the idea is to just simplify them, make them look like that, and then substitute the 64s. So let's do that. So first thing first, you multiply the 3, the exponent 3, you multiply it inside. So the exponent 3, you're going to have to multiply it inside. It's going to be basically 3 to exponent 3x minus 3 all over. And then the square root, remember, this can be changed. Remember, on the one given, you don't have a square root. That is, I erased them too quick. The 5 to exponent root of p equals 64. This doesn't have a square root, so the idea is to remove that. So how you do it is, you just change the square root first to 1 over 2, and then you multiply. So here it's supposed to be minus 3 at the top, not down there. And then, sorry, and then, so basically you want to change this to this. So if you just swap the 1 over 2 and the, basically root of p, you're going to have this. That is, from 5 to 6.1 over 2, root of p, we just swap them. Just take this, you swap them. If you swap them, you're going to have the root of p inside, the 1 over 2 outside. And then the exponent, the 3's, if you separate this ones, that is, now you can separate them like that. Give each base its own exponent, you're going to have that. Now, remember, they said 3 to exponent 9x is equals to 64. So for that, you need 9 here. So in this case, you have a 3 there. Like they're doing here, you have a 9 here, here you have a 3, so you have to deal with that. This one, it's sorted. You just need to replace this with 64. So to do that, you just have to put a cube there. Basically put a cube there to accommodate for that. How? We know that in this case, that means you're going to have 3 to exponent 3x, then we put a 3. Why? Because we want to have a 9 there. When you have 3 to exponent negative 3. All over. This one you can change it. You can just put 64, 1 over 2. Now, to accommodate for this 3, what I would do is I would put 1 over 3. That's how I would do it. It cancels out. But then I don't cancel, I just multiply the 1 inside. So that means I'm going to have 3, 9x, 1 over 3. I multiplied this 2 only. Then the 1 over 3 is outside. Why? Because I want 9 here so that I can replace the whole thing with 64. Again, remember it's without the use of a calculator. So you have to show each step. Now next part is to change this and put it as a 64. So you're going to have 64 all to exponent 1 over 3 times 3 to exponent negative 3. You can change it to 1 over 27 if you want to at this point. 1 over 2. So at this point, you just have to simplify them. Yeah, so let's look at the solution and be quick with that. So the first one, so you have, let me see something. Square root of 64. So, okay, that one at the bottom, 1 over 3. You can change it to 4 cubed. So 4 to exponent 3 is 64. So you can change it and make it 4 to exponent 3, 1 over 3, 3 to exponent negative 3, all over. It doesn't allow me. All over. And then this one at the bottom is going to be 8 to exponent 8 to exponent 2, and then 1 over 2. So at the end you have the 4, that's where the 4 came from. And then they took this one, 8 is there because this cancels that. And then this one, you can take it to the bottom and have it as a positive exponent. That's what they have here. And then you're going to have, to get this 1 over 2, 4 goes once into 4, into 8 goes 2 times. So you have 1, 2, then 27 is 3 to exponent 3. Then you multiply 27 and 2, you get 1 over 54. That's it for 1.3. Let me do another video for question 2. I'll stop here for now.